Okay, our last two lessons, are we all paying attention? Will be word problems. So we're going to have percent changes today and then doubling period and half-life on Monday. I will explain that on Monday. So we'll start off with what happens when we're dealing with percent changes. Exponential growth and decay with the percent change. So all of the word problems you're going to be associated with today, you will see something is increasing by a percentage or decreasing by a percentage. The equation that you're going to use is the following. So f of x is equal to k times b to the power of x. The k represents your initial amount that you're starting with. The b represents your growth or decay rate, okay, which I will explain how we find in a minute. X represents the time period, and f of x will represent your final amount. What?
In our name, instead of B, it says H. Should we switch that to B?
It doesn't matter. It doesn't matter. It just means it represents the base. It's your growth and decay rate. Now, how do we figure out the growth and decay rate? In the questions, you will be given a percentage. So something is increasing by a percentage or decreasing by a percentage. That is not officially your B value. To find the B value, if it's a growth situation, your B is going to be 1 plus that percent change. If it's a decay situation, a decrease, then your B is going to be 1 minus your percent change. Right? So if you were told that, say, the value of a house increases 10% every year, then the B in your formula will be 1.1, 1 plus 10%. Okay? If you were told something is decreasing 5%, then your decay rate will be 1 minus the 5%, so 0.95. Are we good with that? You need to make sure you can identify each of your unknowns to plug it into the formula. Oops. Let's do an example. We've got a class of 26 students carried out the following an investigation to model population change. They decided that their data could be modeled using this equation. So f of x is equal to 26 times 0.85 to the power of x. F represented the number of people standing. X represented the number of trials. So given this equation, what is our value k and what does it represent? What should k be in this equation? K is what value, Ryan? 26. What does it represent? The original initial number of students at the start. Exactly. So the 26 is our K. It represents the initial population at the start of this experiment that they're doing. What is our B value for this equation? Julia? 0.85. 0.85. What does that represent? Which one is it? Is it a growth or a decay? Decay. Why is it a decay? Less than 1. Okay? This is our decay rate. When your base is less than 1, it's a decay rate. Which means, technically, how much is your population decreasing after each trial? If our decay rate is 0.85, after each trial, how much is the population decreasing? 5. Any thoughts about that? Ryan? By 15%. Correct. Okay? We are losing 15% of the population each trial. Or, technically, you could say that the population is 85% of the previous population. Okay, they mean the same thing. When we say our decay rate is 85, that means that after the next trial, the population is 85% of the previous trial. Or, we are losing 15% each trial. How did we get 15, by the way? Just 1 minus the 0.85, okay? Let's use this, our equation to calculate how many students we'll have after 10 trials. So x is 10, just subbing 10 into our equation. So it's 26 times 0.85 to the power of 10. Since we're talking about people, we're not going to leave this as a decimal, okay, since you can't have point of a person. So this should be around 5 something, but we're going to round that up to 6. So, okay, when it comes to questions where you're dealing in whole numbers, so number of people, number of bacteria, those should always be rounded out because you can't have a decimal of a person. If the question deals with money, that's not an issue. You always 2 decimal places for money. But if the question deals with population where you can't have half of something, make sure you round up to the next whole number. Okay with that? And then we use the lovely word approximately. Math loves the word approximate when we have to do rounding things. Yes?
What does that equal symbol mean?
That's the approximate symbol. Equal with a little dot on top means approximate. Okay. So far, so good? Let's do a question where you actually have to figure out the numbers. Can I move on from here? Just looking at the top. So, number 2, we are talking about the value of vehicles depreciating after you've purchased it. So here we have a car company. It says, for an example, a mid-sized vehicle costing $32,950 depreciates 17% per year. We want to know how much the car is worth after 3 years. So I'm going to let X represent the number of years, since that's our depreciation time period. F of X will represent the value of the car, since that's what we're talking about. The K will be the initial cost of the car. So K is the $32,950. Since we're talking about a depreciation, this is a decrease, B is going to be 1 minus the 17%. So our B is going to end up being 0.83. And then we're looking for what the car's value after 3 years, so X is 3. Subbing it in, we get approximately $18,840.38. Questions about that? You can calculate the B just like I've done here within the equation, or you can figure out B on a side and then plug it in. It's up to you how you choose to figure out the B. It still must be somewhere you do it either within the equation or on the side. You do need to go 1 minus that percent change. Questions about that? It's very straightforward. Now this is where it gets a little tricky, going the opposite way. In B, we're asked approximately how long will it take for the car to be worth $10,000. So in this question, we're solving for X, the exponent. To do this, so f of X is the 10,000. We're solving for X. So the first thing we're going to do is divide out the $10,000 divided by the $32,950. And then what we have to do is what we did yesterday. We need to figure out the common base. But this isn't going to be as easy as the ones we did yesterday because those ones you had recognizable bases. Unfortunately, what you're going to have to do is take the base 0.83 and then not really trial and error, but then estimate what you think. You're going to try just putting in exponents until you get to a number close to this value. Jacqueline.
Sorry, how did you get 0.8?
We divide the 32,950.
Oh, you divided by
10,000 divided by 32,950 gave us the 0.3034. So what you're going to do in your calculator is you're just going to plug in 0.83 and then estimate values of your exponents. Now, I don't expect you to start at 1 and work your way up, right? The first one I would probably try is, well, we already know that 3, when your exponent was 3, we hadn't gotten there yet, so you shouldn't be picking anything less than 3. I would try 5 or 6 and see what you get. 0.83 to the power of 6 is 0.326, so we still have more to go. Go up another one. 0.83 to the power of... Oh, I just did 6, didn't I? Hold on. 0.83 to the power of 6. No. 0.83 to the power of 5. 0.83 to the power of 7. Oops. 6 powers. Yes, you'll see. You just keep trying exponents. What we want to do is you don't want to go under this number. So you see when you look at the 6 versus the 5 versus the 7, 7 you've gone up under it. So we approximate this to the 6. You're not going to ever get, when you're talking about word problems, you're not going to get a perfect, this is exactly this number. That's why we have the approximate equal sign rather than just straight equals, unless I give you numbers that actually can reduce, but I won't. So you're just going to get an approximate, the closest, you're picking the closest exponent, it gives you closest to this number. Okay? Does that make sense? And then again, we love the word approximate, so that kind of is a nice symbol. It's not exactly 5, but it's approximately, it's not exactly 6, it's approximately 6 years. Again, in grade 12, you're going to be able to calculate these types of questions to an exact value. Here, we're only calculating it to an approximate value. Does that make sense? You're just plugging in your base, picking exponents until you get to an answer that's close enough to the number you're trying to get to. Good? Questions? Let's try the next one. 3. It says Sally is training to run the Toronto Marathon. She starts running 5 kilometers for the first week and increases the distance run by 10% every week. So this is an increasing question. We want the distance she will run after 3 weeks of training. So in this case, my time period is weeks, so X represents the number of weeks. F of X will represent the distance she runs per week. Her first initial run was 5 kilometers, so that's the K value. Since we're increasing her the amount run every week, B is going to be 1 plus the 10%. So it's now a plus since we're increasing. It's a minus when we're decreasing, plus when we're increasing. So here is 1 plus 0.1, so that's 1.1 is our B value. And for A, we're looking to see how much she should run on the 6-week period, so X is 6, which gives us an approximate 8.86 kilometers. So she should be running, in week 6, she should be running almost 9 kilometers. We can shorten approximately, by the way, to just approx. Or about, yes, that's another good word, about. Okay? I'm not going to be too picky if you don't use the equal sign with the dot. Okay, so don't stress about that if you forget. But definitely in your concluding sentence, you should use the word approximate or about, or sometimes you can even use the word around. But usually the word approximate is the best word to use. Question about that? the bottom here. Questions? So another similar one where we go in the opposite direction for B. So approximately how many weeks will it take for Sally to run a half marathon, which is 21.1 kilometers? So here we are given f of x, and again we need to figure out what x is, our time period. So 21.1 is equal to the 5x. This is going to bug me. There should be equal signs right under equal each other. That bothers me so much. Oh. There we go. Oh. Right underneath. Right. Hello. Never mind. I'll fix it later. So, first thing you're going to do is divide the 5. So 21.1 divided by 5 gives us 4.22. And then just like in the previous example, you're going to take your base 1.1, and then you're just going to estimate an exponent. Try to find the exponent that gets closest to matching the 4.22. Now you'll notice this exponent is 15, so it may take you a while, but really you should be judging with the numbers. Again, don't start off with 1 and go to 2 and go to 3. You should probably start at 5 or 6 and then base it from there. When you do 1.1 to the power of 6, you get 1.77. So does that mean you should then try to the exponent 7? No. The 6 was so small, then you need to jump a little higher. Go to 1.1 to the power of 10. And you're at 2.6. So again, that means you need to take another big jump. If you are close, then you should only go up by 1 exponent. But if you still have ways to go by 2s or go by 3s. Okay, I don't expect you to be going 1.1 to the power 2, 1.1 to the power 3, 1.1 to the power 4. You need to look at your answers and see how much of a jump you need to do. Yeah.
It can be under the number.
It can't. Yeah, I don't want you to go like under it. I just want to get the closest one. And honestly, if you did pick, because what's 1.1 to the 16?
It's 4.5.
Yeah, 1.1 to the 16 is a little bit higher, and 1.1 to the 15 is a little under. Try to go with the closest one.
So
The closest one under that number. Is that what I said?
no.
Just pick the closest one. If you pick, again, this is why it's approximate. If somebody gave me 15 and then somebody else gave me 16, I'd probably give it both as the right answer, because it's the one that's closest to what we're looking for around the area.
Okay.
Yes. That's why we love the word approximate, so that we can kind of a free way of getting out of it. Okay? Does that make sense? Questions about that? The biggest issue here is just making sure that when it's an increasing question, it's 1 plus the percentage. When it's a decreasing question, it's 1 minus. That's where I see most people make the biggest mistake, is they switch it. Always remember, if it's increasing, your answer should be getting bigger. If it's a decreasing question, your answer should be getting smaller. So if you have a question where you are told a house is increasing in value, and you want to know how much it should be after 10 years, and the answer you get is less than what you started with, you've done something wrong, because it's increasing. Okay? Always keep that in mind. Sometimes I know you guys get rushed and when you have tests, but those kinds of things people skip over and just write the answer down without thinking about what's happening in the question. You'd be surprised at how many times I'll give you a question like the house. The house originally was $500,000, and after 10 years of increase, it's only $200 and something thousand. And I'm like, wait a second, the house is supposed to be getting bigger in value. How all of a sudden it's half the size? So keep that in mind when you're reading your question. Questions about that? Okay, that's the lesson.